Hi everyone, we're going to be starting chapter 3. This is section 3.1, which is on quadratic functions and models. I do want to preface this chapter as it is a very difficult chapter to lecture over. There's lots of theorems and things of this nature, so there will be times where I just refer to our textbook to have you point out some of those theorems and so forth. I'm not going to spend the time writing all of them down. I do want to make sure to kind of just spend a lot of time going through some examples so that you can understand how we work with some of these ideas. But that's a little later. In this section, though, we are talking about quadratic functions and models, and we've seen this function before. So first of all, our definition, and that takes up quite a bit, but a quadratic function is a polynomial, and we will define what a polynomial is in a section coming up. But it is a function of degree 2, simply meaning that the exponent on our largest variable piece is 2. I also want to point out it does look something like this. So f of x, so that's our notation for function. Looks like ax squared plus bx plus c. A, b, and c are real numbers. We can talk about quadratic functions in the complex world. Then it gets very difficult, but we're going to stick with the real numbers. We usually spend most of our time working when a, b, and c are rational numbers, so fractions, whole numbers, occasionally decimals, but we usually change them to get rid of decimals, but we'll deal with that later. I do also want to mention that a cannot equal 0, because if a were 0, that piece would be gone, and we'd have bx plus c or something smaller, and then we would no longer have a quadratic. If the x term was there, it would be linear. If the x term was also gone, we'd have a constant function. So we have to have that x squared term in there to have a quadratic. A quadratic function, and this will be some of the pieces that we're going to go through, is, again, of this form, ax squared plus bx plus c. And we can, through some completing the square, get it into the form that looks like a times this x minus h squared plus k. And this is considered to be our standard form. I will point out that this a and this a are the exact same number. H and k do have some importance, because what will happen is this graph, the graph of our ax squared plus bx plus c, will be a parabola. So we've seen the basic parabola and we have shifted it. And you'll notice when we write it this way, it will shift h units left or right, depending on the sign of h. This will stretch it, and then this shifts it up or down. So that 0, 0 point is going to move to wherever hk is. So our vertex is going to be that hk. Furthermore, if a is positive, it's going to open upwards. If a is negative, it's going to open downwards. And we're going to spend a little bit of time, okay, a lot of time, actually getting some of these into that standard form, learning how to go through that, completing the square, and then graphing a rough sketch of what these things look like. So that's where I want to start. I'm going to go through one example here, maybe another example in another spot, but before I do that, I want to give another piece of information, and that is a max or min, max and minimum. And I want you to picture parabolas, so those u's opening upwards or downwards. And we're going to let f be a quadratic function with standard form. So we have done the work. F of x equal to a x minus h squared plus the k. the max or minimum value. I did abbreviate maximum, minimum value of f occurs at x equals h. And we will note if a is greater than 0, so that means we have a positive a, which meant it will open upward, so kind of think of upward. So this value here the minimum value, we will have a minimum value of f is f of h, which is also equal to k. So it would be the y value at x equals h, which does turn out to be k. And if you put h in here, you'll notice you'll have h minus h, which is 0 squared, which is still 0, and that'll turn into that k. But it is also the y value at the vertex, because this vertex is the point h, k. So h is the x value, k is the y value. If a is less than 0, then this thing is going to open downward. So instead of a minimum value, we're going to have a maximum value. Is f of h, which is also equal to k. So the same idea, but maxes versus mins. Now the hard part, of course, is to get this thing into that standard form. So I do want to go through a couple, one in this video, and I'll start the next video with another one. So starting with f of x equal to 2x squared minus 12x, and let's do plus 13. Okay. So the first thing I am going to do, and this is the kind of the steps that you want to go through, is you need to get that a out front. And we also have that k, kind of that constant piece all by itself. So what I'm going to do is I'm going to factor the 2 out of both of these two pieces. So that's going to turn it into a 6x. And I'm going to close off that parenthesis. I'm going to push this plus 13 way to the end. So I've just kind of done a little bit of algebra. I factored a 2 out of the squared term and the x term. We might get fractions here. We will deal with that in another example. I'll probably do a couple of examples in that next video, just to make sure. And now what we're going to do is complete the square. And we have completed the square before. So we take this x, whoops, that should be a squared on there. And we're going to take half of this, so this is going to be a minus 3. That's going to complete this squared piece, but we have to complete the trinomial here. And if you remember, this becomes half, and this becomes squared. So this will be a plus 9. It will always be positive. Okay, but we can't just put plus 9 here, because that changes what this original thing was. So we kind of have to undo what we just did. So by putting this plus 9 here, it actually, looking here where this would be distributed, we're actually adding 18. So in other words, to undo the adding 18, we have to subtract 18 as well. So now we can take that 13 minus the 18, which is a minus 5. So now we have a quadratic, which is going to open upward because of the positive 2. It's got a vertex at 3, negative 5. And we can also plot some other important pieces. The important pieces that we want to plot are, so we need some other points to kind of get an idea of what it looks like, is we're going to find those x and y intercepts as well. Okay, so and then we'll get a more detailed graph of what this thing looks like. Okay, so far all I know is it opens up. It's got a vertex at 3, negative 5, but I can find my x and my y intercepts. I'm going to start with the easy one, my y intercept. intercept. Okay, so I'm going to kind of fill this in as we go too. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so I know that it's going to be 3, -5, and it's going to open up. So it should look something like that. Okay, to find out where that y-intercept is, we let x equal 0. And we learned this in the last chapter, chapter 2. To find y-intercepts, we let x be 0. And so we find out what f of 0 is. So I'm going back into my function. So I get 0 minus 0, 13. So f of 0 is way up here. So kind of imagine it off my paper a little bit. Let's find those x-intercepts. And since this is a parabola opening up, I know that I'm going to have 2 of them. So there's going to be 2 of them. And to find those, we're going to let y equal 0, because they're going to be on that x-axis where y is equal to 0. So we're going to take this guy and set it equal to 0. Okay, which means we need to factor it if possible. If it doesn't factor, we will go to the quadratic equation. So I'm going to try to factor. So here I am looking for, let's see, multiplying those two together. That's 26. I'll put that down here. I'm looking for 2 numbers that multiply together to give me 26, that add together to give me a -12. The only 2 numbers I can think of that multiplied is the 13 and the 2, and that's not going to work. So we will be going to that quadratic equation. So lots of good review in this example. Our quadratic equation is a -b plus or minus square root b squared, so 144, minus 4ac all over 2a. And now we have to simplify that. So we have 12 plus or minus. All right, so I need to do this work here. 144, so let's see, 4 times 2 times 13, I am using my calculator, is 104. So 144 minus 104 is 40, all over 4. Going to clean this up because there's a perfect square in there, namely 4, so I can pull out a 2. Cleaning it up even more, pull out a 2 out of everything here, 6 plus or minus square root of 10 all over 4. That cancels, all over 2. Okay, now we are trying to figure out a rough graph. So I kind of need to know where in the world this 6 plus the square root of 10 divided by 2 is. So I'm going to be using my calculator. So I'm going to be taking 6 plus the square root of 10. I'm going to get that value, so get that first before you divide by 2. And the adding one is like 4.5811, and there's more decimals. Make sure you can do this arithmetic on your calculator. So I'm putting those numbers on here for you so you can check. And we have those values. So I need to kind of put those in. So 1.4, well, that's about here. 4.58 is about there. And I can kind of rough it up right there. I do know another point, since this is nice and symmetric. I also know that I'm going to be at 613, remembering that that parabola is going to be nice and symmetric. Okay, so there is how we can complete our square, find our vertex, which is also our minimum. So we have a minimum value of negative 5, and it happened at x equaling 3. So we kind of put all of that into one idea. I'm going to stop the video here, and I'll come back with another example of doing some quadratics. So we'll go through another completing the square so that we get some practice, and we'll also graph it so we'll find some intercepts and so forth. So in the next video.